The next property we're going to talk about is how to locate local maxima and local minima. Maxima and minima, you might not hear that, we don't really hear that very often, but maxima and minima are just the plural of maximum and minimum. We don't want to say find the local maximums and minimums. No, we say find the local maxima and minima. And we can see the two examples up here. A local maximum would occur at a high point. When f changes from increasing to decreasing, we have a high point. Therefore, we have a local maximum of f of c at x equals c. So be careful. Make sure you get that terminology down. Okay? We have a local minimum of f of c at x equals c, and that's what that says right there. So be careful with that terminology, because I will ask you what is the maximum value, and you have to say, like for example, if this, let's say these are the coordinates 2, 7. Okay, I would say what? Oops, you can't even see that. Sorry. I would say if these are the coordinates 2, 7, I would say what is the maximum value? You would say the maximum value is 7, and I would say where does that occur? You would say at x equals 2. Okay, so sometimes that could be a little confusing, so try to make sure you camp out on that so that doesn't confuse you. Here's some definitions for you. Again, the definitions make horrible videos, so we're skipping those. We'll cover those in class. And a couple things I need you to do here for this next slide. I need you to fill in that open circle. So on my sheet of paper it looks like an open circle, but it's just really intended to be a closed circle here. So let's take a look. Let's just answer the questions and see if you can answer them before I do. At what number or numbers, if any, does f have a local maximum? Okay. At what number? At what number? So like where does f have a local maximum? And you would say at x equals 1. Very good. I'm confident you got that. And then, so for part B, what are the local maxima? Well, we have, notice these arrows here. The arrows mean that it goes up and up forever, and we would not say that the maximum value is infinity, because infinity is a concept. Infinity is something that keeps going. Okay, we use infinity to indicate, oh, that's just going to keep getting higher and higher. So that would have no maximum value besides right here, because that's the only high point that is actually a real number. So what are the local maxima? Well, we only have one. We would just say local maximum value, max value of 2. And it happens to occur at 1. Again, infinity is not going to ever be a maximum value. Okay? See if you can answer this one before I do. But before you do that, fill in these little circles here. Okay? My paper is really small. So when you fill in the little circles there, you get you have 3 points. You have 2 low points and 1 high point. At what numbers, if any, does f have a local minimum? Well, we can say we have 2 low points. Right here at x equals -1 and at x equals +3. And what are the local minima? Well, we have 2 local minima, and one of them here is at y value of 1, 1, and 0. So 1 and 0 are both minimum values. Okay? Cruising right along. Finding local maxima and local minima from the graph. Where is the function increasing, decreasing, or constant? So again, try to do these before I give you the answer. Okay. List the intervals on which f is increasing. Going down here. Pause the video if you need to have a little bit more time. And we go from -1 all the way to +1. And also from 3 to infinity. And now, just real quick, the difference between parentheses and brackets, technically the function is neither increasing nor decreasing at the points, at the ends of each of these intervals. So, but sometimes some books actually use brackets for those numbers. But we will not use brackets. If you use brackets, you will not be marked down. And I just always use parentheses if we do not include the endpoint. And for increasing, decreasing, or constant, it really doesn't matter what you use. You can use brackets or you can not use brackets. You can use parentheses. Okay? So f is decreasing, let's see, from negative infinity all the way here to negative 1, combined with the interval from 1 right there, the x value of 1, all the way to 3, because we're going downhill during that section. Okay, we're about halfway there. Let's take a look, and the next slide we're going to see is we want to identify absolute max and absolute min, and all that is just the highest of all the locals. Okay, so absolute, we do a little activity. Ask me about that in class. It's a fun little visual that I can give you guys in class. So basically, the bottom line is it's the highest, the absolute maximum is the highest local max, and the absolute minimum is the lowest local min. So it's that simple. But there's your definition, and if you want that, go for it. But we're going to go ahead and go on to the next example. And again, we need to fill in some of these circles. I think that what happened was this is color on my slides, but when I print it black and white, it doesn't come out very well. So the absolute maximum of, so we can see we have a maximum there, right there, at 3,6, and then we have another maximum here at 5,5. It can be a maximum even at an endpoint if the function is increasing up until that endpoint like that. So we have two maximums. What's the absolute? Well, it's the highest one. The absolute maximum value of 6 occurs when x is equal to, we can see the ordered pair there, when x is equal to 3. Okay? And we have an absolute minimum of, well, we have a minimum there and a minimum there. The lower of the two minima is right here. So 0, 1, the absolute minimum of 1 when x equals 0. Okay? And what I'm going to do here is pause the video, and I'm just going to fill in all the answers for the rest of these because they're all that's pretty redundant. So go ahead and I'm going to pause it, but I need you to pause it as well, and then when I start it up again, when you hit play again, all the answers are going to be there. Okay, yeah, one thing. Sorry, all the answers aren't there. I just want to make sure that you filled in the correct dots. There is a dot there, solid circle. Okay, that's solid, but this one down here actually is an open circle. Okay, that's an open circle. It's a hole. You can see it right there. It says hole. Down here, in this example, we have these circles filled in and that circle filled in as well. And then this one over here also has a closed circle. Okay? Now pause it. Okay, time in. Here we go. Absolute max of 3 occurs when x equals 5. There's no absolute minimum because of the hole at x equals 3. We've got 4, 5, 1, and then this is where it gets a little tricky sometimes. The absolute minimum value can occur at more than one place. So this absolute minimum value of 1 happens to occur on this entire interval from 1 to 2. Okay? And then we have no absolute max because the values of the function keep getting bigger. And then absolute minimum of 0 when x equals 0.